we just demoed some basic Git functionalities, and now let's go back to the underlying data structure. I believe the most effective way of learning Git is to showcase some of the functionalities so you get some basic understanding, then you go to the components, the inner working of this Git. So first, when you work with Git, you are working with a bunch of source code, right? That's the working directory, and the files you can directly see and manipulate and edit. So that's the working directory. And this is should be very, very easily understood. So these are the files, source code, that you can directly work and edit in your integrated development environment like Visual Studio Code. You can save them, make changes, save again. Now the staging area, which is the orange part, is a hidden, actually two hidden folders under this .git folder, this hidden folder. So the staging basically it tells you, okay, I made changes to these files. I'm happy with all the changes. Now I'm going to using git add to stage the files. In practice, git add and git commit happens almost always at the same time. So you made a bunch of changes, you stage them, then you commit right away. So this commit basically takes a snapshot of all the staged files and save them into a mini database, a hidden database. The database also lives under the .git, same hidden folder, same guy here, .git. So that's the repository. So the repository is the most important part because it saves all the snapshots of your historical code. If you screw up, you can always check out a historical version. That's the git checkout. And git add basically tells Git, I'm happy with all these changes, let's commit, and next time we commit whatever has been added. If we made further changes after git add, the further changes will not be committed, will be discarded, unless you add git add again. So you can consecutively add git add, yeah. In practice, we rarely worry about this git add because they happen at the same time. These two arrows are merged, yeah. Your ID usually has like a little button you click and it will stage and commit at the same time. So snapshot is taken of all the codes. And here is the remote server. We can use git clone to copy all versions, the histories from a remote server if you want to use some other people's code. Or you can use git push to push a specific branch, the head of that branch, which I will explain later, to a remote server. You can also use git pull to pull. Also, there's a command called git fetch. The git pull is basically you grab some version from remote server and merge with your the current branch, which is the git pull. The git fetch, you basically grab the data but without merging. Yeah. So git pull or git fetch is basically you getting data from the server, and git pull will also merge the data, the snapshot from the server with your current branch. The git push, you push your current branch to the server. So that's basically 4 areas of Git. Your local Git has 3 areas: the working directory, the staging area, and repository. Local repository and remote repository will have another database saving all the snapshots. From this graph, you will know that the commits are the most important part because both the blue and green are repositories. So the database, they save all the historical snapshots. So next, let's talk about these historical snapshots. So this is another graph I grabbed from internet. I hope you guys can see it. So only little things that we made 3 commits. Git commit message blah blah blah. Git commit. So you made some changes, you commit. You made some change, you stage the change and then commit. So the rightmost commit is the latest one. You should not be confused by these arrows. These arrows always point to the ancestor. So this is the first commit. You made changes, the second commit. You made some further changes, the third commit. So every commit has one ancestor. Of course, if one commit comes from a merge action, it will have 2 ancestors. So these guys are simple commits, linear, yeah. And you can see these commits, they are associated with number of trees. A tree always points to a blob or another tree. So what is a tree? So the commit is just a pointer pointing to a snapshot of all the files. Where do the files come from? It could be a new file that you modified. This file, you create a new file, or you modified an existing file. Then Git will create a blob, which is a file. Blob is a chunk of data associated with a single piece of source code, a single file. So if you have 10 files, source code, you commit it, then you modify the two files and commit again. So here, what happens, you have two new blobs because two files have been modified, or you create a new file, it will be another blob. Yeah, you have a tree pointed to a bunch of blobs, and it will also point to another tree which will always eventually point to some blobs. The tree just leads you to the file. The reason you have trees is that if I modified only two files and there's a total of 10 files, I just keep two new blobs, and the 8 files I just point to the previous tree, right? I don't have to duplicate all the 8 files again. In Angular project, you may version control 500 different source code, pieces of source code. You make changes to only 3 of them. You don't want to copy all the 497 again to take a snapshot. The snapshot is composed of new blobs or new files or modified files and pointers to previous files. So these trees basically point to previous files or a new blob, a new file. So that is a commit. A commit is no more than a pointer. By the way, this video is about Git tutorial. It's not 101 computer science. So if you don't know what is like a pointer, what is a hash table, feel free to check them out. But here I just give you some high-level explanation. That the pointer is just a variable storing some memory location, so it can grab data very quickly. The hash table is just a database you store the kind of memory location. It's another way of getting data very quickly. So these are basically stuff pointing to a memory location. So the commit is no more than something pointing to a memory location that stores all the historical files and pointers to historical files, and each file is called a blob. And these guys live in a database, and there's each each file has a hash key, so you can access the files very quickly. Now, I didn't talk anything about the tag. This tag is no more than just a pointer, same as commit. Like if you're happy with your changes, you release the software, you can tag it as version 1.0.0. Just you associate it with a commit with some text annotation. Unlike commit, you have a lot of commits, the tag is basically static. You associate one commit, a certain version, with some text. Feel free to check it out. Git tag, what it does. Yeah, it's very easy. Now you know that commits are just pointers pointing to a snapshot. And the snapshot is composed of either new files, the blobs, or a tree that points to previous files. If you didn't change the file, you don't have to make a copy, right? So these are just the commits, pointers to historical snapshots. And it also points to the ancestors, so you can compare differences, which files you have modified. Now, let's talk about a branch. So what is a branch? A branch is just another pointer pointing to a commit. So these 3 commits, the granddaddy, the daddy, and son, this is a branch. This is a linear structure, very simple. And the branch just point to these guys, and it always point to the latest, the head of that branch. The head of the branch is just the latest commit. It's automatically named head. You see, previously I demoed, if you made some changes, you even staged the changes, then you realize, oh, crap, these are not good. I want to discard everything. What did you do? Git reset _hard and then capital letter HEAD head. Git reset hard head. You discard all your changes and revert to the latest commit of this branch. The latest commit of the branch is called head. So these are all pointers. You are dealing with a bunch of pointers, and this data structure is a little bit convoluted. You have between your commits, you have this. If there's no merging, you have these pointers pointing to their ancestors, and here it's apparently a bunch of pointers pointing to the blobs or other trees. Yeah, the tree point to other trees. So now you understand what a commit is, what a tag is, and what a branch and a head is. I hope this will help you understand the materials I will cover later.